So, generally speaking, controlled drug production and use tends to concentrate around four drugs or drug types. So, we have cannabis, we have opiates, cocaine, and amphetamine type substances. We will discuss each of these together with a brief overview of NPS or new psychoactive substances. So these four substances can be categorized through their mechanisms of production as naturally occurring, such in the case of cannabis, semi-synthetic materials derived from natural products, such as opiates and cocaine, and synthetic products, such as amphetamine type substances, and the NPS. For the full list of prohibited drugs in the Philippines, read Annexes RA 9165, or you may also want to read Article 2 of RA 9165 for unlawful acts and penalties. Chemicals used in drug manufacture are divided into two categories. First is the precursor, and the other is what you call necessary chemicals. Precursor chemicals are chemicals that are essential to the production of a controlled substance and for which no substitution can be made. In other references, precursor chemicals are termed scheduled substances or drug precursors, which are used in the illegal production of narcotic drugs and psychoactive substances. Essential chemicals or necessary chemicals are used in the refining of the chemical processes. For example, the refining of coca and opium into cocaine and heroin. Although some remain in the final product, the basic raw material is the coca or opium. Several essential chemicals required for illicit drug manufacture have extensive commercial applications. These chemicals are widely traded and are available from numerous source countries. You could check the complete list of controlled chemicals in the Philippines through the official website of PIDEA. Aside from classifications, another important thing to remember about chemicals is how they are taken either at a crime scene or thereafter, as this pose obvious consequences for any subsequent investigation of the crime. We term this as sampling, and a few important things must be kept in mind while doing sampling of evidences. So this is mostly applicable to all types of evidences, but let me mention it here before we go over the different types of evidences to analyze. So a few things to keep in mind. One is that the consequence of incorrect sampling may result in unusual or unusable data and potentially incorrect and improper conclusions where the adage of rubbish in equals rubbish out may easily apply. Another is that the sample integrity must be maintained, which means that the sample gathered should be the sample to be analyzed, and the result obtained should really come from that sample. Another is that information regarding the sample is paramount, whether it has been gathered at the scene and transferred to the laboratory for analysis or has been generated in situ in the laboratory. Correct recording of the circumstances of the samples are essential. So if you do this in the future, you need to include information as to who has handled it, for how long, and why. There are two things that generally dictate sampling protocols. The first one is the legal obligation that may require that all items in a seizure are described and sampled. The other is the policy left to the expert that will include a description of the items and the selection of a sample from the items. The sampling strategy is fully dependent on the questions being asked and the problem that has to be solved. There may be different needs for possession, production, or trafficking, and you may be asking the following questions. Is a drug present? So in this case, you need minimal sampling, which may require just one positive result. Is a drug present in more than a specified proportion of the items, or is a drug present in all the items? So in this case, all the samples need to be examined. The first stage in any procedure where sampling is to occur is an understanding of what it is that needs to be achieved. So this will depend upon what type of sampling is being undertaken, whether sampling is occurring at the crime scene and the nature of that scene, or sampling at the laboratory. So whichever scenario is faced, there are a few universal objectives. The first is that the sample should be representative of the material in question. The other is that the sample should be randomly chosen as appropriate. Number 3, the sample should be of adequate size for the analysis to be performed and to allow subsequent analysis to take place. The basis of sampling is that the composition found in the samples taken reflects, in principle, the composition of the whole. As a consequence, only a fraction of the total packages in a seizure should need to be investigated. Although the sampling protocols may vary slightly among laboratories, but of course these laboratories are being accredited and regulated by the DDB, or the Dangerous Drugs Boards, in the case of or in our country, no, in the Philippines. So we have crime laboratories too, where most evidences are analyzed. I say most because I don't know much about the availability of this analysis. I mean, I don't know the capacity of our crime laboratory, but I'm positive that our provincial crime laboratories are capable of analyzing methamphetamine, or commonly known as shabu, and maybe other common prohibited drugs. In cases where samples of powder are seized, it is necessary to ensure that the powder is homogeneous. This is generally accomplished using one of the three methods. So the first is cone and square method. So in cone and square method, the sample is ground up first and then poured onto a flat surface and flattened. The material is divided into quarters at right angles and one quarter shaped into a cone. So the cone is quartered again at right angles and a quarter chosen, and so on. So this process is continued until a sample of sufficient size is prepared. Another method is shaking in a plastic or nylon bag. So the sample is placed in its entirety into the bag and shaken to mix it. So this can result in larger particles falling to the bottom of the bag, or particles of the same of the sample preferentially adhering to the sides of the container because of charge differences depending on the size of compounds that may be present. That's what we call blending. So sample is placed into a blender and mixed mechanically. So this method is very effective in homogenizing samples, but it must be ensured that the blender is completely clean. Sampling protocols will also be dictated by the nature of the analysis, identification, quantification, profiling, or sampling at clandestine laboratories. Powders and tablets and packages. So for single package of material, so the material should be removed from all packaging and weighed to a constant dry weight. The sample is then homogenized and a sample is removed. So if we have more than one package, the material in each package should be examined by eye for color differences. So the contents of each package should be weighed, cleaning the balance in between each weighing, and each package should be tested using a color spot test or TLC, or what we call the thin layer chromatography. If it is assumed that all packages contain the same material, then this one, if less than 10 packages, so all should be tested. So if there are between 10 and 100 packages, the 10 should be tested. If there are more than 100, if there are more than 100 packages, the square root of the total should be tested at random. For liquid samples, if all is of one phase, then a sample of the liquid is removed for testing. But if there is more than one phase present, then a sample of each phase should be removed for testing. You also need to know about control and comparison samples. So there are normally two types of control samples. The first one is positive control or comparison controls, and the other is negative controls, or sometimes the same as blank samples. Okay, so let's end this video here. So let's end our discussion here. In the next video, I will discuss the types and how each is analyzed and used as evidence. So thank you for watching.